So last class we had discussed about AC through resistor and inductor. Let's today AC through a capacitor. Okay, give heading AC through a capacitor. AC through capacitor. Correct. So let this is a capacitor. Correct. One AC is connected. Okay. This value is C capacitance, and E is equal to E naught sine omega t. Right. When an alternating EMF is applied to a capacitor, then current is constituted in the circuit. Yes or no?
Yeah.
And due to that current, the charges on the plate and the electric field between that plates of the capacitor very sinusoidal, because we are giving the sinusoidal voltage, right?
Huh.
Yes or no?
Yes.
And let Q be the charge on the capacitor at any instant. Let Q be the charge on capacitor. Q be the charge on capacitor at any instant. Correct? तो यहाँ पर अगर हम किरचॉफ्स लॉ डालेंगे, ठीक है, यू नो Q इज इक्वल टू व्हाट? CV ना? So V
Yes.
is equal to how much? Q by C?
Q by C.
Yes or no?
Yeah.
So how much voltage we are giving, that will be dropped across the voltage across the capacitor, correct?
Hmm.
So the voltage that we are giving, that is E naught sine omega t, correct?
Yes.
That can be equal to what? Q by C. Yes or no?
Yes.
Q by C is voltage across the capacitor, correct? है कि नहीं?
Huh.
So we can write Q is equal to, we can write cross multiply करके C E naught sine omega t. Can we write or not?
We can.
Yes or no?
Yes.
That is C E naught sine omega t. You know current I is equal to dq by dt na?
Huh.
Current is rate of flow of charge, right?
Yes.
So C d by dt. So this in place of q you can put C E naught sine omega t, right?
Yes.
And what is the derivative of sine theta? Cos theta, correct?
Sin cos theta.
Yes, cos omega t into omega, right?
Huh.
So it will be C E naught. Derivative of C E naught is coming out. Derivative of sine omega t is omega into cos omega t, right?
Hmm.
Not. So you can write here that is C omega E naught into cos omega t is sine 90 plus theta, na?
Hmm.
Or we can write sine omega t plus pi by 2. This is what? The current. Yes or no?
Yes.
And this is the maximum current if you will compare, right? I is equal to how much? Right? This is maximum current I naught. Sine omega t plus pi by 2. And you know in capacitor, the current leads, correct?
Yes.
You are giving this much value of voltage. E is equal to E naught sine omega t, correct?
Yes.
But the current that is coming, that is I is equal to I naught sine omega t plus pi by 2. Yes or no?
Yes.
This current is the instantaneous value of alternating current, right? This is what?
Instantaneous value of
Instantaneous
alternating.
value of alternating current, right?
Yes.
Correct. And how to find the peak current?
I naught is equal to C omega
I naught is equal to C omega E naught, correct or not?
Yes.
So क्या हम इसको इस तरह लिख सकते हैं, ऊपर में E naught को रहने दो नीचे में 1/ωc लिख सकते हैं क्या?
Yes, and that is XC.
So that is E0/XC, correct?
Yeah.
Yes or no?
Yes.
तो फाइनली यहाँ पर क्या मिला आपको? Current leads the EMF by an angle of pi/2, correct? So we got
Hmm.
current leads the EMF by an angle pi/2, right?
Hmm.
By an angle pi/2. Understood?
Yes.
That means अगर फेजर डायग्राम ड्रॉ करेंगे, ठीक है, if we'll draw the phasor diagram, that we are taking voltage as the reference, means EMF is the reference, right?
Hmm.
This is the value of EMF, correct? Voltage, right? This axis we are taking current and EMF, and this axis we are taking as omega t, right? Then you can see the current
Yes.
is going to lead. Going to lead means it's going to start early, correct?
Yeah.
So it will be like this, correct?
Huh.
Understanding or not?
Yes.
This is going to be the current, correct?
Yeah.
If this is 0, this is pi/2. This is also, yes or no? हम यहाँ पर ऐसा लगे, this is 0, this is pi, this is 2 pi, correct?
Yeah.
This point is what? Pi/2, correct? And this point is 3 pi/2. And this red line is current. Current started early, yes or no?
Yes.
So if I'll draw the diagram like this, if this one as I'm taking as alternate current IC, then voltage lags. That means voltage will be in this direction, right? VC. And that is near
Yeah.
about absolute value is pi/2. Correct?
Hmm.
Yes or no?
That's the phasor diagram.
Yes, that's the phasor diagram. ठीक है?
Yes.
तो अभी एक चीज हमने और यहाँ पर नोटिस की है, जो यहाँ पर है I is equal to E0, ठीक है? This is another thing. उसके ऊपर थोड़ा डिस्कस करते हैं, ठीक है? The resistance offered by a capacitor to the flow of AC is called what? Capacitive reactance. क्या कहते हैं उसको?
Capacitive reactance.
Capacitive reactance. That is XC, correct? Yes or no? And XC
Yes.
is equal to 1/ωc. Omega is equal to 2 pi f, so that is 2 pi f into c, correct?
Yes.
Yes or no? So that is equal to how much? Maximum EMF by maximum current. If we'll divide, then also you can cite that is ERMS by IRMS. Yes or no?
Yes.
Same thing can be written anywhere as per as requirement. We can use the formulas, right?
Huh.
Understood?
Yes.
अच्छा, कैपेसिटर, ठीक है, मतलब कैपेसिटर एक्सी, कैपेसिटर्स का कितना रिएक्टेंस होगा वो किसके ऊपर डिपेंड करता है? मतलब एक्सी कितना होगा वो किसके ऊपर डिपेंड करता है? ओमेगा सी के ऊपर डिपेंड करता है.
Yes.
That also depends on frequency.
Yeah.
ओके,
Yes.
अगर मैं डीसी ले लूं तो डीसी का फ्रीक्वेंसी कितना है? 0.
0.
तो एक्सी क्या हो जाएगा डीसी के केस में? 1/0 मतलब
Infinity.
इंफिनिटी, वेरी हाई.
Yes.
That means it will block DC. Capacitor blocks DC, right?
Yes.
We can take a conclusion. Capacitor blocks DC. Correct?
Hmm.
Yes or no? And AC को जाने देगा, bypasses AC. Bypasses AC. Okay?
Yes.
अगर उस तरह जैसे हमने वहां पर ड्रॉ किए थे, एक्सी और फ्रीक्वेंसी का कर्व में ड्रॉ करना चाहता हूँ, राइट? तो कैसे रिलेटेड? इनवर्सली प्रोपोर्शनल, राइट? If this axis is XC and this axis is omega or F, then you can see this is right. It will be like this.
Yeah.
The capacitance is constant, right?
Huh.
Yes or no?
Yes.
If anyway, if the same graph will be like this, let in this axis we are taking as XC, and in this axis we are taking as capacitance, then it will be also like this.
Okay.
is omega constant, correct?
Yeah.
Resistance हो, impedance हो या reactance हो, right? Same units are, they're having same units and same dimension, right?
Hmm.
Correct?
Yeah.
आप कहीं भी पूछ लेता है सिली क्वेश्चन नीट वगैरह में, रेजिस्टेंस हो या इम्पेडेंस हो या फिर रिएक्टेंस हो, राइट? ऑल हैव सेम यूनिट्स, करेक्ट?
Yes.
हम डायमेंशन फार्मूला, राइट? है कि नहीं?
Hmm.
हम्म, ये सबका ऐसा यूनिट क्या है?
Ohms.
ओम। डायमेंशन फार्मूला जैसे निकाल लेते हैं, एम एल स्क्वायर टी टू द पावर माइनस थ्री ए टू द पावर माइनस टू, राइट?
Hmm. Yes.
पावर सप्लाई टू ए कैपेसिटर भी देखेंगे, इंडक्टर का देखे, रेजिस्टेंस का देखे, राइट?
Hmm.
तो लेट्स सी पावर सप्लाई टू ए कैपेसिटर, पावर supplied to a capacitor, correct? Let's see power supplied to a capacitor, instantaneous power supplied to the capacitor pc, let I into v, I is equal to what? I not cos omega t, right?
Hmm.
v क्या है? v not sin omega t, है ना?
Yes.
अगर क्लास में ले आएंगे I not v not cos omega t into sin omega t लिख सकते हैं,
Yes.
yes or no?
हाँ.
एक टू अंदर में मल्टीप्लाई कर सकते हैं, एक टू बाहर में मल्टीप्लाई कर सकते हैं, जब बाहर अंदर में मल्टीप्लाई कर देंगे तो साइन टू ओमेगा टी हो जाएगा ना,
Hmm.
तो साइन थीटा इंटू कॉस थीटा, राइट?
Sin 2 theta.
करेक्ट।
Hmm.
ये हो गया मेरा इंस्टेंटेनियस पावर,
Hmm.
एंड एवरेज पावर ओवर ए कंप्लीट साइकिल हमेशा क्या होता है? जीरो होता है,
Yes.
यस सर नो?
Yes.
ऐसे भी अगर हम एवरेज पावर निकाल ले, पी एवरेज मींस वी आर एम एस आई आर एम एस कॉस फाई, और यहाँ पर वोल्टेज और करंट के बीच में एंगल 90 डिग्री है ना,
Hmm.
तो वी आर एम एस आई आर एम एस कॉस 90, तो कितना हो जाएगा? जीरो हो जाएगा ना,
0.
पी एवरेज इज गोइंग टू बी जीरो, करेक्ट?
Hmm.
तो हम ये लिख सकते हैं, नो पावर इज कंज्यूम्ड इन ए प्योरली कैपेसिटिव सर्किट, राइट?
Hmm.
नो पावर is consumed in a purely capacitive circuit, correct? ठीक है?
Sir, even for
Inductor,
inductor,
yes, yes,
even for inductor, the pre-average will be 0.
yes, 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 yes. Understood?
Yes.
Let's do a very few easy examples now, right?
Yeah.
ऐसा दिया हुआ है कि एक अल्टरनेटिंग वोल्टेज दिया हुआ है, E is equal to how much? 200 root 2 sin 100 t, correct?
Hmm.
Understood? और इसको हमने कनेक्ट करवाया एक कैपेसिटेंस से जिसका वैल्यू है 1 माइक्रोफैराड, राइट?
ठीक है.
तो पूछ रहा है करंट कितना होगा, मतलब एक एमीटर अगर लगाएंगे तो करंट कितना होगा? एमीटर हमेशा कौन सा वैल्यू रीड करता है?
Current.
करंट का कौन सा, एवरेज या मैक्सिमम या आरएमएस?
RMS.
आरएमएस। अगर एमीटर का रीडिंग पूछा है तो मतलब आई आरएमएस पूछा है, राइट? यस सर नो?
Yes.
इसको अगर हम अभी देखेंगे, राइट, तो यहाँ
Sir,
ओमेगा
since
की जगह में कितना है? ओमेगा की जगह में 100 है ना,
hmm,
और ई नॉट कितना है? 200 रूट टू।
200 root 2. So ERMS is 200.
यस, ओमेगा इज इक्वल टू हाउ मच? 100 रेडियन पर सेकेंड,
Yes. So 2 pi f is equal to
एंड एक्स इज इक्वल टू 1 बाय ओमेगा सी, That is 1 by 100 into 10 to the power minus 6, correct?
Yes.
That is equal to 10 to the 4 omega.
हाँ.
Sorry, ohm. Understood?
हाँ.
अगर IRMS निकालेंगे, if I'll be finding IRMS, then that is equal to ERMS by Z, correct?
Yes.
And that is ERMS is E naught by root 2 है ना? और यहाँ पर Z है तो only XC है, no resistance, no inductance, right?
No.
200 root 2 जो कि दिया हुआ है क्वेश्चन में, right?
Yes.
4 divided by root 2 into 10 to the power 4.
4.
तो
Yes.
पूरा सॉल्व कर देंगे तो कितना आ जाएगा? रूट 2
into
कैंसिल,
10 raised to
20
2
milli
into 10
ampere, right?
raised to minus.
This is going to be 20 milli ampere. Understood? Hmm. Understood?
Yes, sir.
तो इस तरह की हम कर सकते हैं क्वेश्चन, इजी क्वेश्चंस, राइट? I will give you the assignment, you will see that, correct?
ठीक है.
Understood ना?
हाँ.
Next, let's see through AC through LR series circuit, okay? We'll see LR, we'll see RC, then we'll see LC, then we'll see the LCR, right? Now you got AC through inductor, AC through capacitor, AC through capacitor and resistor, right?
Yes.
Individually we saw all.
Hmm.
Let's see now AC through LR series circuit, correct? Let's see AC through LR series circuit, right?
Hmm.
Understood?
Yes.
Let's see. AC through LR. Both inductor and resistance will be there, correct? Let's draw one inductor. Let's draw a resistor. Let's give the AC to this, correct? This is L, this is R, and this is E, correct? And both are connected in series. So this is let voltage drop across inductor and let this is voltage drop across resistor, correct? And the E that you are giving, that is nothing but E naught sine omega t, right?
Yes.
And let I amount of current is flowing, and you know VL is equal to I into inductive reactance XL, correct? And voltage through resistance also current remains same, I into R, correct? Yes or no?
Yes.
And here inductor, I lags voltage by pi by 2, right? Current lags the voltage by an angle of pi by 2. Yes or no?
Yes.
अगर हम यहाँ पर रेफरेंस लेंगे, अभी अगर मैं अभी फेजर डायग्राम बनाऊं, लेट्स मेक द फेजर डायग्राम, राइट? X axis and Y axis. If on this axis we can take VR, voltage across resistance, और R लिए हमने, right? है कि नहीं? तो रेजिस्टेंस के लिए करंट भी सेम फेज में रहता है ना?
हाँ.
But VL will do what? Current lags and voltage leads. So this is XL or voltage drop across VL, correct?
Yes.
So the net resultant EMF will be in this direction. That is E. Understood?
Yes, sir.
If we are taking this one as B and this one as O and this one as A, right? As we find resultant OC, O to C, let this one, right?
Yeah.
तो यहाँ पर क्या होता है? I lags the voltage. I lags the voltage VL. I lags the voltage VL by pi by 2, correct?
Yes.
Then OC can be written as what? OA का square plus OB का square का root over, correct? Yes or no?
Yes.
That is VH square plus VL square root over, correct? Understood? So now, by combining the equation, you can put the value R means E is equal to total net EMF E is equal to VR it I square R square, correct? VL is IXL. That means I square XL square root over. Getting?
Yes, sir.
I square taking common, inside there will be r square plus xl square.
Huh.
Yes or no?
Yes.
What is xl? Omega L, inductive reactance. Yes or no?
So R square. Okay, yeah.
Hmm. So you can find I is equal to how much? E by r square plus xl square root over. Hmm?
Hmm.
That is known as impedance. E by Z of LR. Right? Z is equal to how much? R square plus xl square ka root over. That is impedance. Right?
Yes.
R square plus xl is omega L, so you can keep in bracket omega L whole square. The value of omega will be given in the question, and the value of inductance will be also given in the question. By multiplying, finding the square, then adding with R square, taking the root under, you can get the impedance.
Yeah.
Correct?
Huh.
See here, if I'll be taking this angle, sometimes we can take also phi. Let this angle is phi. We can take tan phi. If this is XL, this will be XL. Correct?
Hmm.
Here also I can take tan phi. We got the value, but we want to find the resultant. At what angle it is making with the horizontal or vertical. If I'll take tan phi, I can write XL by R. Correct? Tan phi can be written as XL by R, or that can also be written as VL by VR. Are you getting from the triangle?
Yes, sir. I got it.
That is VL by VR, or because VL is equal to what? IXL. VR is equal to what? IR. I cancel. So that is XL by R. We can write also.
Hmm.
So we can write in conclusion, tan phi is equal to omega L by R. Right?
Okay.
This is about the magnitude and the direction, correct?
Hmm.
Okay.